Hello dear students, welcome to DAV Mall Public School. I hope you are doing great with the chapter of light. In today's topic, we will discuss about spherical mirror. Earlier you have studied about light, different phenomena associated with light, reflections of light, multiple reflections and etc. In today's video, we will study about spherical mirrors. What are they? So what exactly do you mean by spherical mirror? It is quite identical to plane mirror, but the difference it is that it looks like a sphere, which is a hollow. So what exactly do you mean by spherical mirror? A mirror which is polished and whose reflecting part is a part of hollow sphere of glass is called a spherical mirror. So what exactly do you mean by this statement? If we take a hollow sphere which is made up of glass and coat one side, for an instant, if I'm coating this side with a material such as silver or lead oxide in such a way that one side becomes an opaque medium. So what do I mean by this statement? It means that light will not pass through that particular surface. So it means this side this side of this hollow sphere becomes an opaque medium, and inside this hollow sphere it becomes a reflecting surface. So this is the same, this is indicated over here. A hollow sphere is there in which this portion is coated in such a way that it becomes a hollow, and inside it becomes a reflecting surface. When the when a spherical mirror which is bulging inwards and the reflecting surface is inward, it is termed as concave mirror. So your inner hollow sphere is a reflecting surface. So inside this, the inner portion is bulging portion, this inner one is a curved one, hence it is termed as concave mirror. In short, you have to remember that whenever a curved portion is there in case of mirror, curved cavey sort of structure is there. As you can see, concave, the word itself speak cave. Cave means a sort of hole, a sort of you can say a sort of bulging inward portion. That is nothing but a concave mirror, a cave sort of thing. So this cage sort of thing is nothing but a concave mirror. Whereas with a similar emphasis, if the outer portion is bulging one, in this case the inner portion is coated with lead oxide and a material of silver. So inside this hollow sphere, the inner surface becomes an opaque surface and the outer surface acts as a reflecting surface. So the bulging portion over here, it is outward, hence it is termed as convex mirror. So here the outward portion is a reflecting surface, here the inward portion is a reflecting surface. So let's proceed with the next slide. Now let us understand some of the terminology which are associated with spherical mirror. Now in this video, some animations are there which will help you out even in 10th standard and all. So analyze this video and try to understand this video with a good frame of mind. So I'm considering a hollow sphere. This is a hollow sphere. Inside there is a vacuum sort of thing. A hollow sphere is there. Imagine this is a hollow sphere. In this portion, I have indicated this portion. This portion, it is acting as a convex mirror. Here it is the reflecting surface is outward. Here the reflecting surface is outward, and inside it is acting as an opaque medium. So in this hollow sphere, this portion acts as a convex mirror, whereas over here the outside portion, it is acting as an opaque medium, whereas inside this sphere it is acting as a reflecting surface. So hence it is a cavey sort of cage structure, a cave structure. Hence this surface is a reflecting surface. So this is a reflecting surface over here, hence it is termed as convex mirror. Here inside is a reflecting surface, hence it is termed as concave mirror. Now, if we consider a slice of this hollow sphere, and if we take the midpoint of that slice, it acts as a pole. So in short, you can say the midpoint of a convex mirror, the exact center of this convex mirror is termed as pole. Whereas over here, the exact center of this concave mirror is termed as pole. So this is the center of this portion. I am considering my mirror from this portion, the last line over here till last line over here. So the exact center would be over here somewhat. So the center of this concave mirror is termed as pole. In the same way, I am considering from here till here as a concave mirror, the exact center would be termed as pole. Pole, in short, you can use the symbol P to indicate pole. Now, a straight line which is passing through the pole. And now, since I am considering one important thing, that is, if I am considering this as a hollow sphere, then it is an obvious that it would have a center. That center, it is known as center of curvature. When a straight line passes through the pole and the center of curvature is located exactly at the center of curvature. It is termed as center of curvature and it is used by the symbol C. When a straight line which is passing through pole, center of curvature is termed as principal axis. A principal axis is there which passes exactly through the pole, center of curvature is principal axis. As I was telling earlier, the exact center is termed as center of curvature. It is denoted by C. Now, since I am considering the whole thing as a hollow sphere, a part of this concave mirror, of imaginary thing, part of hollow sphere, whereas this concave mirror and imaginary hollow sphere is there. Since it has a center of curvature, so there's an obvious thing that it would also have a radius of curvature. So what exactly do you mean by radius of curvature? The distance, it is simply a distance between pole and center of curvature. For this convex mirror, the radius of curvature is indicated from this arrow till this arrow. Whereas for this concave mirror, the radius of curvature is from this point till this point. So hence it is termed as radius of curvature. Both these are radius of curvature. This is the radius of curvature of convex mirror, whereas this is the radius of curvature of concave mirror. So collectively I wrote radius of curvature. Now, if I imagine a ray of light which is going in this direction. This yellow portion is a ray of light which is going in this direction. Now, since it is acting as a reflecting surface, this a bulging portion, it is acting as a reflecting surface, it is convex mirror. So after this ray of light hitting this concave mirror, it will get reflected. Now, so when the ray of light touches the concave mirror, it will get reflected and it will travel in this direction. And as we have studied in plane mirror, whenever light gets reflected, it obeys a certain laws. That is, angle of incidence and angle of reflection are equal. So at this point of incidence, I'm drawing a normal. So here the small angle, that is indicated by angle of incidence, whereas over here another angle is created which is known as angle of reflection. And as per the law of reflection, angle of incidence is equals to angle of reflection. So the same thing is happening over here. Now, with the same emphasis, I am considering a ray of light for concave mirror. Here I took an example of convex mirror. Here I am taking an example of concave mirror. A ray of light which is suppose flowing in this direction. Now, since this inside portion is a reflecting surface, so after hitting this portion, it will get reflect according to the law of reflection. So it will pass through in this direction. So this is here also angle of incidence and angle of reflections would be equal. I will draw a normal over here. This angle of incidence and this angle of reflection would be equal. Now, If I consider the example of concave mirror, one rule is associated with it. Whenever a parallel ray of incident light, when a parallel ray of incident light, parallel in what circumstances? Parallel with the help of principal axis. Whenever a ray of light which is parallel to principal axis, it will always, after reflection, it will always pass through a certain point. That point is known as focus, or more precise, principal focus. So whenever this ray of light and is parallel to the principal axis, so after reflection, the ray of light will always pass through one certain point. That certain point is termed as principal focus or simply focus. Here it was in the case of concave mirror. Now in convex mirror, since it is a diverging nature, so ray of light is this, after reflection it would appear to pass through focus. Here it was in reality passing through focus, but here after reflection it would appear to pass through focus. So what exactly is the focus? The distance between pole and center of curvature is the focus. In another way you can even say that distance between pole and center of curvature is focus. For this convex mirror, or in this case the distance between center of curvature and pole is exactly midpoint between center of curvature and pole is focus. Here it was after reflection ray of light was passing through focus, whereas over here ray of light after reflection would appear to pass through focus. In reality it is not passing, but it would appear to pass through focus. Hence this line I will extend in such a manner that it will exactly pass through the center of pole and focus. So center of this pole and focus would be over here. So the reflected ray of light will always pass through the focus. So the focus might be over here. So if I extend this ray of light backward, it would pass through focus. Here I am using the statement, it would appear to pass through focus. Here in this case, it was exactly in reality passing through focus. So this is the indication of over here, it is passing through focus. So this term is known as principal focus, and this term is known as principal focus. For this concave mirror, this is focus. Here also it is focus. Now, the distance between pole and focus, it is focal length. Distance between pole and focus is focal length. It is indicated by small f. So that's why the distance from pole till focus is small f for this convex mirror, whereas the distance between pole and focus is focal length for concave mirror. So this distance is focal length and this distance is focal length. I hope you have understood the concept of this thing. One thing you can add on, like whenever a ray of light you are considering, if you are extending normal, it will always pass through center of curvature. For an instant, if I am considering this situation, I have two ray of light, this ray of light, this ray of light. This is incident ray, this is reflected ray. The point of incidence is over here. So the reflecting, I'm drawing a normal. So this normal will always pass through center of curvature. If I extend this case in backward direction, it would always pass through center of curvature. With the same emphasis, incident ray, reflected ray, I'm drawing normal for these two rays. If I extend that normal, it will again pass through center of curvature. I hope I've tried my level best with certain animations. If you pause, listen properly, you will understand this concept very nicely. So if you haven't understood, pause it and again play it. You will understand this properly, and it is very important topic for solving numericals and all. The same thing, whatever I have told, certain definitions are written over here. You can go through this. What is center of curvature, radius of curvature, pole. You can correlate with whatever I have told in this explanation part. Yes, one important things which I did not told. Focal length is half of the radius of curvature. What do I mean by this? This focal length, if I am considering the distance between pole and center of curvature is r, so the distance, what is the focal length? Therefore, here that is here f portion. it is always r by 2, r upon 2. Whereas over here, it is always r by 2. Since it is simple logic, if you consider from your portion, center of curvature till pole, the distance is r. So what would be half of it? It would be r by 2 for this. Whereas if the distance between pole and center of curvature is r, radius of that is radius of curvature, half of half would be r upon 2. So here exactly at f small f is equals to r by 2 for this mirror as well as for this mirror. That's why it is written focal length, that is small f, is equals to r by 2. I hope I've cleared all your doubts and all. Thank you and have a nice day.